Whew, we're going to fly through this section. This one won't take too long. We're here at section 2.3, part 2. And what we're going to talk about today to finish out this section is what's called the intermediate value theorem. Okay, intermediate value theorem. I call this one our growing theorem. The reason why I call it a growing theorem is this. When you were first born, here we are, first born. Itty bitty little baby. Okay. You're first born, we're going to call you, say you were a big baby. You were 19 inches tall. Now we take a look at yourself. Okay. Take a look at yourself now, this time big. Here you are. Getting a little bit bigger, got bigger legs. Okay. Let's see how tall you are now. Now you're, let's say, 3 inches tall. All right, 5'3". All right, so 63 inches tall. You've grown a lot. My question is there a time, okay, were you ever 44 inches tall? The answer better be, it better be yes. There's no way you light speed it up and all of a sudden, you know, in less than a second you jumped, you know, that many inches. No. Okay, you weren't all of a sudden 43 inches, then 45. You grew past 44 inches tall. So the question is yes. So what the intermediate value theorem says, if I start, okay, this tall, at this time, at the beginning here, at your beginning, and then at the end of my time, I am ending at this height, and at this end height, that sometime in the middle, we'll even change colors here. We'll call this middle time. I was in between the height. In between. Okay. And that's true everywhere. And so that's what it mathematically says up here. It says a function that is continuous on a closed interval AB takes on every value between f of A and f of B. And you can see that, right? Here I am at A to B, and I can see that every value from here up and down is covered at least once, sometimes twice. Okay? But at least one time I am every single height in between. You might be thinking, duh. Well, it's true, duh. Okay? But this is important to be able to say as far as the theorem. And this is, you know, if I have a continuous function, that's the big one. If I have a continuous function. And those are all those 3 points. You know that my function value is defined, that the limit as I go to that, as x approaches that c, exist, and that my function value is equal to my limit value. Okay? That happens everywhere. If that happens everywhere, then I can say this. And this is what makes our continuous functions nice and smooth. Okay? So maybe not seem like a big of a deal, but it's a huge deal. Okay? So basically what I'm able to say on this one, if I know it's a function is continuous, okay, and I know what f of A is, and I know what f of B is, that I can make knowledgeable statements about what f of C is. So let's see here. Think. So the intermediate value for continuous is the reason why a graph of a function continuous on an interval cannot have any breaks. The graph will be connected, a single unbroken curve. It will not have jumps or separated branches. So what I want to show you here, okay, is how this can be useful. Because if I give you something like if f of x is continuous, and then I tell you that f of 1 is equal to -4, and f of 5 is equal to +8, does the function cross the x-axis? And then you might be asked to justify. And so then you'd be asking yourself, well, duh, of course it crosses it. Because it's telling me it's a continuous function. I have f of 1 is -4 and f of 5 is a +8. Of course it's going to cross the function x-axis at one time. Of course it is. But how do you justify it? How do you say it? So the way that I would say this was that be since f of x is continuous. That's what the hypothesis is, continuous, of the intermediate value theorem, OUS. So because it's continuous, then I can say that the intermediate value theorem, IVT, applies. And then you would be able to say, since f of -1 is equal to 4. Let's try that again. F of 1 is equal to -4, and f of 5 is equal to 8, then there is a C such that f of C is equal to 0. That's your justification for it. Okay? Let's go. And it should be like, again, a no duh, but this is the writing part. This is the formal part. This is what you have to be able to write down. All right? So next we come down here. Hey, I'll take a moment for you guys to just read that. It's where you can chuckle a little bit. Ha 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 ha. Okay? All right. We'll take what's next. So when I take a look at this one, why can I not use the intermediate value theorem on this function? Again, what was my hypothesis? All right? My hypothesis stated that my function must be continuous. Is this function continuous? The correct answer, hopefully it's in your head, is no. It's not continuous. Okay? So the intermediate value theorem cannot apply. All right? And that's it. That takes us to our homework. All right, so I'm going to go ahead and let you guys take a moment to summarize what you about the intermediate value theorem. Okay? And what it means, you know, as when I can use it. And so be thinking about that. I look forward to reading your summaries. I look forward to seeing you guys tomorrow. All right. Please bring your questions tomorrow. All right. Bye.